there, as Professor said at the start of the class, that we can use decision tree as one of the techniques to predict or recommend something to some items to the user. So as we know, decision tree is a collection of nodes where most of the cases it's a binary node, but it can be a multi-node as well, where it creates a set of rules based on the purity of the nodes, and it tries to use that classification rules of this decision tree to predict a new case. So like decision tree is a supervised learning technique where you have a target value and you have a set of features which will be mostly differentiated to be a categorical variables and then used to split them into further rules. Can you go to the next slide? The different types of measure, you can measure the similarity using different distant metrics like as Banu was speaking, you can use Jaccard distance or ecosine distance and things like that. So, can you go to the next slide? So based on the duality of similarity, as we mentioned multiple times, there can be similarity between the users and similarity between the items or the products in itself, and you can use either of these to predict or like predict what is the best for the user. That's it. Yeah, and clustering users and items. This would be taken care by other team members in the next class. Sorry that he couldn't make it to this presentation. Yeah.
Somebody has to present their stuff. Is that what they wrote or not?
Yeah.
So just go on and read it.
Yeah, so clustering users and items. So the problem with this is if two items belong to the same journal, there are likely to be very few users who bought these. So the problem with content-based filtering is like somebody has to manually give in the features of an item. So if there is there are a lot of items that are released out there, and Amazon cannot, or like any company cannot manually give in all the features that are needed for an item. And you can't actually uniformly use information from different sources altogether as well. So if there are few websites, like for example, I take information from Facebook and Pinterest and say Google+. All the information formats or the feature or even the language across the country spoken is different. So somebody has to unify all this and make sure. That's one of the problems with content-based filtering. By selecting any of these distant measures suggested like the Jaccard or the cosine similarity, we can see what's the similarity between the items and users and do it. And then clustering of users using these similarity index. So similarity measures. Yeah. To the next slide. So UV decomposition. As you see, if we start with the utility matrix M, which I initially spoke about with N rows and M columns, that's like N users and M items. Then we might be able to find a matrix Q with N rows and D columns, as you see. And a matrix with B with B rows and D columns, sorry, and such that UV closely approximates M in those entries where M is not blank. That's what we'll be looking at, a UV decomposition, and this is a simple example of a UV matrix, a U and then V. To the next slide. So there are like a lot of cost functions or loss functions that can be used. As you know, there's one popular Netflix used ALE, alternative least squares, to recommend to predict the recommendations for their users. And similarly, one of these techniques is RMSE, an incremental computation of UV decomposition. Next slide. That's it. That's all. Thank you.